This video is about review for derivative continued. Look at the 5a. Let f of x equals x squared. The following diagram shows part of a graph of f. The line L is the tangent to the graph of f at the point A, negative k squared, and intersects the x-axis at point B. The point C is negative k0. Write down derivative of fx. That will be 2x. Because we do this x squared, do the derivative, that will be 2x by using the power rule. For the B, find the gradient of L. We know the derivative means gradient of a tangent line. L is a tangent line. Therefore, the gradient of L will be derivative of f of negative k. We just plug in negative k to this derivative. You will get negative 2k. Show that the x coordinate of B is negative k over 2. Since we are given coordinate and also we got this slope, we're using y minus y1 equals slope x minus x1. We plug in. You will get the y minus k squared equals negative 2k times x plus k. Since for B, that is x, here's 0. So we plug y equals 0 here. We plug into this tangent line equation. You will get the 0 minus k squared equals negative 2k x plus k. Therefore, we divide by negative 2k. Because this is a 0, it's gone. Negative 2k. You will get k over 2 equals x plus k. Since I'm solving for this x, we subtract k. Therefore, the x equals negative k over 2. For the 5D, find the area of triangle ABC. Because this one is a right angle. Here's a right angle. X coordinate for B, that is a negative k over 2. Which means the distance between these two, it will be k over 2. The height is k squared. Therefore, your area equals 1/2 base, that is k over 2 times the height is a k squared. You will get the k to the third power over 4. Now let's go to 6a. The values of the function f and g and their derivatives for x equals 1 and x equals 8 are shown in the following table. Let h of x equals fx times g of x. Find the h of 1. H of 1 we plug in to this function. You will get the f of 1 times g of 1. From this table, we know f of 1, that's 2. G of 1, that's 9. So 2 times 9 equals 18. For 6b, find the derivative of h of 8. First of all, we need to figure out the derivative of h of x equals f of x times g of x. We have to use the product rule to work this out. You will get the derivative of x times g of x plus f of x times the derivative of g of x. So we plug in derivative of h of 8 equals derivative of f of 8 times g of 8 plus f of 8 times the derivative of g of 8. So we plug in derivative of f of 8 is here. So you get the -3 times the g of 8, that will be 2, plus f of 8 will be 4 times derivative of g of 8, that's 5. So you get -6 plus 20 equals 14. Let's go to 7a. The following diagram shows the graph of f of x equals 2x squared for a squared minus x squared for x is between -1 to a, where a greater than 1. The line L is the tangent to the graph of f at the origin. The point PAB lies on L. 1. Given that derivative of fx equals this. For x greater than equal to -1 and less than a, find the equation of L. We know L is the tangent line at origin. We have 0, 0. We need to figure out the slope so that we can get the equation of L. We use y minus y1 equals slope x minus x1. We already know that y1, x1 equals 0. Therefore, you will get the y equals mx. For this m will be derivative of f of x. Therefore, the slope equals derivative of f of 0. We plug in 0 into this derivative function. You will get 2a squared minus 4 times 0 squared over square root a squared minus 0 squared. You will get 2a. Therefore, y equals 2ax will be the equation of L. Hence, or otherwise, find an expression for B in terms of A. Since PAB is on the line L, in other words, we can plug in x equals A, y equals B into this equation. Therefore, you will get the B equals 2a times a. B equals 2a squared. This will be the relationship between A and B. That's it.